So let's talk about frequency and period. Well, maybe we should set up a scenario first. There's this fly, and it flaps its wings. 150 times per second. I would like to know what the period, find the period, of one wing flap. And when I say find the period of a wing flap, that means find out how much time it takes for one wing flap to occur. So period is a measurement of time. So how could you do this? Well, let's see. If there's 150 times per second, that means that 1 second has gone past. And the flaps have occurred 150 times, so if I want to know how many seconds, or maybe even what fraction of a second it took for one wing flap to occur, maybe brainstorm out what would have to be done here. We'd have to think, I just want to think in terms of units. It would be 1 second per 150 flaps. And you know, a flap is a kind of cycle, and cycles don't have units. You just count them. So it's just a count, no units. 1 second per 150 flaps. I want to get out my calculator there. 1 divided by 150 is 0.00 and then 6 repeated. And so on. Seconds. Now, let's just pretend that flaps was a unit. It's a count, but let's pretend. 150, flaps. That would mean that it's 0.006 repeated seconds per flap. That sounds like a period to me. How much time it takes for one flap to occur. So I want to take a look at this. This is very, simple thinking. Take a look at what we could call these values in terms of variables. What I'd like to call them is the amount of time that I observed something for. In this case, I only observed it for 1 second. And the number of cycles that I observed. I'm going to use n for, it's the common variable used for integer. It's an integer count, a whole number count of the number of cycles. So if I want to know the period of time it takes for one cycle, it's the amount of time I observe something that cycles for divided by the number of cycles that occur. And I'm going to call that the period. And a period is a measure of time. So just to differentiate between delta t, which is going to be the amount of time that I observe it for, and time that it takes for one cycle, I'm going to call time for one cycle capital T. And that is the widely used variable for what most people call the period of oscillation. Okay, so we've got the period of oscillation, and in this case the period of oscillation is 0.006 repeated seconds for each flap. But we really don't use flaps as a unit. It's kind of false, just to help us think through this idea for the first time. How about this one? We can call this one example 1. Let's call the next one example 2. Find the frequency of rotation for a second hand on a clock. I know that a lot of people out there use digital clocks exclusively. I always think that the good old-fashioned analog clock looks kind of handsome. So I'm going to use my good old-fashioned analog clock, and I know that on an analog clock, that second hand zoop goes all the way around the face 1 time every minute. So again, we're talking about an oscillation here. I'd like to know what the frequency is. Now, frequency is a word that I think pretty much everybody, even if you haven't taken anything in physics or even any higher grade maths, know what frequency really is. It comes from the same word as frequent. So frequency, or how frequently a cycle repeats, is what we're talking about here. Now, frequently, I go and visit my parents. Frequently, I take my children for walks. Frequently, I enjoy a sunny day. How frequently something happens has to do with how many times it occurs per unit of time, or how many occurrences per unit of time. In this case, how many cycles per unit of time. So we could talk about cycles per second, cycles per unit of time. So now that we know what frequency is discussing, cycles per unit of time, let's talk about an actual clock. Well, for one cycle, how many seconds does it take? If it's a minute, it takes 60 seconds. So if I wanted to figure out what the frequency is for a second hand rotating around a clock, 1 divided by 60, let me get my calculator out here, 1 divided by 60 is 0.01, and then the sixes repeat, 0.016 repeated. And again, I said before flaps isn't a unit. I'm going to cross out cycles. I could pretend that it's cycles per second, but nobody really writes it that way. They might be more likely to write it as 0.016 repeated 1 over seconds, or even more frequently 0.016 repeated seconds to the power of -1, which means the same thing, but probably even more frequently, and you might have seen this on your electronics equipment, maybe, I don't want to infringe on any copyright, but your iPhone or on your microphone or whatever it is, most people are going to think of it as 0.016 repeated hertz. Named after Heinrich Hertz. You can look that name up yourself. Important guy as it comes to frequency. And so this value gets named after the guy. Anyway, frequency is how many oscillations per second. I want to go back to what period is. It's how many seconds per oscillation. So it shouldn't really surprise you, here's going to be another big equation, that frequency is the inverse of period. Every time I put a box around an equation, put a star beside it, those guys are important equations. And if frequency is 1 over period, then you could also say that frequency is equal to the number of cycles divided by the amount of time that has gone by. I'll put a star beside that one. Another important equation. Frequency and pyramid. I'll do one more example before we wrap up this quick little talk about frequency and pyramid. Let's talk about, a kid on a swing. And we know that kids on swings, do this as a profile shot, kids on swings go back and forth, whee! Having a good time, and they go to one side and back again. And actually, a kid on a swing, except for the fact that it's being driven by the kid, it's kind of like a pendulum. And so if we assume it's a little bit like a pendulum, we could say that it might have a uniform period. Let's just pretend that this kid is a nice little pendulum on a rope swing. And if this kid has a period, much like a pendulum, maybe keeps time on a clock, keeping time on the playground here, I want to say that this kid, pardon me, makes 5 swings every, nice round numbers, every 10 seconds. So here's the question. What is the period for a swing? In other words, how many seconds does it take for one swing to occur? And then the follow-up question is, what's the frequency for a swing? And by swing, I mean a complete cycle. This way, then back again. So, let's talk about what our variables are here. Here I've got 5 swings. That's a count. That's an integer count of how many complete back and forth motions occur. 10 seconds, that's the amount of time I watched this kid swinging on the swing. 10 seconds. Period for a swing, alright, that's how many seconds per oscillation. The period of time for one oscillation, we call it capital T, is going to be equal to delta T divided by N. And I'm going to format this horizontally because I foolishly left myself too little space. Delta T, 10 seconds, N, 5 swings, no units. I want to make my mother proud. 10 divided by 5 is equal to 2 seconds per oscillation. 2 seconds is the period. Frequency, I kind of got choices here. I could say frequency is equal to N over delta T, instead of delta T over N. And I could say 5 oscillations divided by 10 seconds is equal to, of course, 0.5 oscillations per second, which is the same as saying seconds to the power of -1. Or you know what, I'm going to break down this time and just say hertz, because I like that good guy Heinrich, and I really like hertz. Reminds me of the pastry shop that he opened up. It's called Hertz Donuts. He hit a lot of people when they walked in the door. Alright, anyway. We got 0.5 hertz, 2 seconds, period, 2 seconds, frequency 0.5 hertz. This is a fine way to figure it out, but an equally fine way to figure it out, if I've already done this calculation, is to say that frequency is equal to 1 over period, which would be the same as saying, alright, 1 divided by 0.5, and this time I'm not going to write it as hertz, just to emphasize my point, I'm going to write it as 1 over seconds. And 1 divided by 0.5, I'll deal with the numbers first, is equal to 2. But 1 divided by 1 over seconds is the same as saying 1 times, I'll just deal with the units here on their own, 1 times seconds over 1, which of course gives us an answer of 2 seconds. Just like we would have gotten, where did we go? Oh yeah. Just like we would have gotten if we took this method here, okay? The units still work out if I do 1 divided by 0.5, 1 over seconds, or equivalently 1 divided by 0.5 hertz. Anyway, that's the short story on frequency and period.